Welcome to this video in which we will have a look at Yest, Smart Testing's visual test design tool that helps creating better tests 40% faster. Yest is the missing tool in a fully tool-supported test process. It allows you to visualize complex behavior of various systems under test. In this example, the system under test is a memory protection unit used for automotive or other safety-critical software. The MPU guarantees freedom from interference of different tasks. To make sure that tasks do not corrupt memory content used by other tasks, memory areas are defined. The MPU then ensures the tasks cannot access memory areas which are not configured for them. The configuration of the MPU can be rather complicated. In our example, we have two cores, thus a task runs either on C0 or C1. In addition, each task is classified according to its safety integrity level. Tasks with ASIL B may cause safety-relevant problems, whereas tasks that are classified as QM are less critical and only subject to standard quality management. Let's have a look at Yest. Here you can see the workflow. The MPU tests are straightforward. First, we have to define the memory segments we want to test. As you can see, we have 7 segments. Apart from the segments with unlimited access and no access at all, we have restricted areas for the cores, special core-specific segments for ASIL B tasks, and one shared area to exchange data between ASIL B tasks from different cores. Next, we define the task we want to execute when we run the test. To have complete coverage, we should test both QM and ASIL B tasks. Also, we have to take the cores into account. In total, we have 4 combinations, as you can see in this table. But the most interesting table is this one. This is where we specify the expected result. The first line shows the test of the segment with free access. We expect the task to run without problems. The second row specifies the test of the segment with no access at all. In this case, the MPU will detect an access violation and cause the ECU to reset. As you can see to the left, this behavior is expected regardless of the core or the task's safety classification. The next 4 rows show the test of the core-specific areas. Any task, be it QM or ASIL B, may access those segments if run on the core the segment is reserved to. If not, we expect again an ECU reset. We also expect an ECU reset if QM tasks try to access segments that are reserved for ASIL B tasks. But of course, ASIL B tasks may access their dedicated segments, but again, only and only if the core matches. Finally, the last 2 lines test the access of ASIL B tasks to the shared memory area. Let's return to the test workflow. There's one final step where we check whether the ECU reset is correctly performed. In this step, we use the value true or false set in the previous table. What you've seen till now is the test design. We analyzed and documented the input and output equivalence partitions. We clearly said in the tables what we want to test and what the expected result is. The next step would be to implement the test cases in detail. But this is the moment when we can sit back because Yest does the work for us. We just have to tell how good the test coverage shall be. Given the fact that we test a safety-critical system, we should not use the standard generation. But just to explain, the standard generation creates the minimum number of tests required to cover all table rows. In our example, it may be used for regression testing purpose, but for the moment we want to have a better coverage. Therefore, we generate tests for all possible combinations of the first 2 tables. In this way, we ensure that we have tested each segment for both QM and ASIL B and for both cores. Yest produces 28 tests, which you can see here, covering all possible combination of tasks, cores, and memory segments. So you get documented good coverage with little effort thanks to maximum tool support. Have you noticed how helpful Yest has been? You now have a clear idea of what I want to test and how. The table showing the 7 segments was extremely helpful, also in explaining the system under test. In addition, it's documented. But that's not all. If an additional core were to be added, we know exactly where to modify the tests. Yest not only generates new tests, but also supports us in revising existing tests. Unlike other MPT tools, Yest does not override any changes that you have made to test cases once they have been generated. All in all, this results in a considerable gain in productivity, while at the same time improving the quality of the test design. Say yes to test.